Hi class, this chapter, chapter 5, is about light and matter and how light interacts with matter and how we ultimately measure things about objects great distances away just by looking at the light that they give off. So the first part of this chapter talks about how light interacts with matter, just some of the basics. This figure that you see here is something we'll talk about eventually, but this is showing what's called a spectrum. And you can see, we'll understand this eventually by the end of the chapter, but you can see red all the way through orange, yellow, green, kind of bluish, indigo-ish, and ultimately purple down here. And you can see gaps in the spectrum. So this is what's called an absorption spectrum, a spectrum showing all the colors of the rainbow except some missing colors. So we'll eventually understand what this is, but to start with we have to talk about just some basics about how light interacts with matter. So how do we experience light? What does it look like? Why do we see things the way they are? Why do yellow things look yellow, and so on? And then how does light interact with matter? When you think about like reflection or absorption and stuff like that. So light has energy, basically. Light has energy, and energy is sort of flowing. The energy comes from the sun in the form of light, and if you wanted to measure energy, you measure it in joules, and we talked about that previously. But when you talk about energy moving in the form of light or other waves, we can talk about how much energy every second flows or hits some surface or something like that. And so energy per second is what's called the watt. If you think about light bulbs, you might buy a light bulb that's a 60-watt light bulb. What that tells you is that that light bulb sort of takes 60 joules of energy every second from your electric circuit, and it tries to turn it into light. Depending on the type of light bulb, it might not be very efficient, or it might be, pretty efficient. It just depends on the type of light bulb. Regular incandescent light bulbs with the filaments inside of them are not very efficient. A 60-watt light bulb takes 60 joules of energy every second from the electric circuit, but it doesn't give that energy back in the form of light completely. It's in the form of, some of it's in the form of visible light. Other amounts, a great amount of the energy is in the form of infrared light that we can't see. And that's why the bulbs are so hot. You can feel that they're hot. And then there's other forms. That's really the other main component. But so there's a lot of wasted energy in the form of infrared light that's not very useful for us in terms of seeing. So anyway, energy per second is the watt. And that's how much energy every second is maybe hitting something, or being absorbed by something, or being emitted by something, and so on. So when we look at white light, we can, and you may have done this before, but here's a flashlight giving off white light, and we're sending it through a little narrow slit just to kind of cut off most of the light. So there's just a narrow little beam of light that comes through here, and it hits this prism. And the glass prism is such that it's just a piece of glass, or it could be a piece of plastic, but the light comes in at an angle so that as the light goes through the glass, the colors separate. When white light is traveling through the air here, all those colors are pretty much traveling together at the same speed, the speed of light. But when light goes into a material, like glass or plastic or something, water for example, the different colors actually travel at slightly different speeds. That causes them to separate. And when they come out, you see a separation of the different colors that make up that white light. And you see red over here, and you see yellowish and orange and green and blue, and ultimately purple over here. So you see that the white light is made up of all these colors of the rainbow, red through purple. So when we talk about how light interacts with matter, there's basically four things that we want to discuss. And one is emission, light given off by an object. Absorption is light being absorbed by an object, the light coming from somewhere else being absorbed by the object. Transmission means that light can pass through an object. If an object is transparent, it transmits a lot of light. If an object is opaque, it blocks or absorbs a lot of light. It doesn't transmit much. So there's different degrees of transmission. A lot of transmission means it's transparent. Not a lot of transmission means it's opaque. In other words, there's a lot of absorption. And then there's also reflection and scattering. That's where the light isn't either transmitted or absorbed, but it's sent in a different direction. The direction of light is changed. So if we look at a movie theater, for example, the projection booth over here is emitting light. Light is coming out of it, and that light is traveling to the screen. And at every point on the screen, light is hitting those points and going in all different directions. And you know that that's true because no matter where you're sitting in the movie theater, everybody can see every point on the screen. So this is called scattering. When light hits some object and it kind of gets broken up into a bunch of different pieces that get sent in different directions. That's called scattering. It's a little bit different from reflection. It's similar but a little bit different. For reflection, we kind of define it as that beam of light coming in and only going in one particular direction rather than in a bunch of different directions. So you can see how this beam of light coming in reflects and goes in only one particular direction. Whereas for scattering, the beam of light comes in and it scatters in many different directions. So if this is a shiny mirror, and if there's a light here shining down on the mirror, a little laser beam, for example, I have to be in a very particular location over here to see that laser beam come off the mirror. I can't see it from every direction. That's different from scattering. If you're anywhere in this movie theater, when light hits the movie screen, you can see it from every direction because of the scattering rather than the reflection. Again, they're similar, they're related, but the words are used specifically, reflection specifically, to mean a light comes in, a ray of light comes in, and it reflects in a very particular way. And if you measure these angles here, the angle between the surface and the beam coming in is the same as the angle between the surface and the beam going out. That's often called the angle of reflection. It's actually defined differently in some books, but the angle coming in is the same as the angle going out. That's often called the law of reflection. So if we look at some other processes, the sun, for example, is an emitter of light. It gives off light, just like a lamp in your room. It gives off light, it emits light. So that's emission. The light from the sun comes along and a lot of things happen to it. It might hit the ground, it might hit the snow, and some of that scatters off and goes off in different directions. Some of it could get absorbed, and that could cause the snow to melt. Some of it could get absorbed by this tree. And we have the tree then giving off some sort of reflecting or scattering, really, green light. All right, that's why the tree looks green, because it absorbs everything except the green light. All right, so the tree by itself is not emitting green light, because if you were to turn the sun off, you would not be able to see the tree. And so that tells you that the sunlight has to be hitting the tree in order for the tree to look green to you. And so the sunlight comes along, it hits the tree, everything gets absorbed except the green light. That gets scattered, and that's why you see it as a green tree. Similarly, this red chair here, though kind of the whitish light from the lamp hits the chair, and all the colors, most of the colors get absorbed except the red colors, and that's what gets scattered in every direction because anybody in the room can see that it's a red chair. That red light gets scattered in every direction, so this person here sees it as a red chair. Again, this chair is not emitting red light because if I turned this lamp off, I wouldn't be able to see the chair. And because I can't see the chair, that means it's not emitting its own light. It's just scattering light from some other source. So those are examples of scattering and absorption, the snow absorbing light, the sun and the lamp emitting light. And then we could have a mirror on the wall, and that's reflecting the light. So the person looks in the mirror and they can see the lamp in a particular place on the mirror because that light is scattering or reflecting in a particular way toward the person's eyeball. The person's chest, the vest is blue because it absorbs all of the light except the blue and it scatters the blue, and so on. Glass, the glass window transmits light. It allows light to pass through it. The walls absorb light. The light can't pass through. And there's also some scattering off the walls as well because you can see the walls from the inside. So those are some examples of all these different terms in everyday use. So here's a little question. Why is a rose red? So think about this for a second based on what we talked about. Is it because the rose absorbs red light? Is it because the rose transmits red light? Is it because the rose emits red light? Or does the rose reflect red light? So which one do you think it is? Well, the rose doesn't absorb red light, right? Because if we shine white light on it, hold it out in the sun, it looks red, right? So it's absorbing. The idea is that it's absorbing everything except red. Does it transmit red light? Well, you can't see through the rose. right? You can't see through it. So if you can't see through something, it's opaque. It doesn't transmit anything. Does it emit red light? Well, it can't. It doesn't emit red light because if you brought it in a room, a dark room, you wouldn't be able to see it. You wouldn't be able to see it glowing red. It would be black. You wouldn't be able to see anything. So it must be reflecting red light. And again, reflection and scattering are very similar. And so we just say that it reflects red light. Technically, it scatters red light because it goes off in all directions. Once the white light hits the rose, the red light goes off in all directions because you can see that rose from every direction. But that's okay. Reflection and scattering are very similar. So we talked about light as a form of energy, and we can talk about energy in joules as a way of measuring it. And then joules per second is the watt. And light comes in many colors that we can separate with a prism. We can look at all the different colors from red through purple. And we talked about these different ways that light can interact with matter. Emission, absorption, transmission, reflection, or scattering, and so on. And then we can see these instances of all these different things in pretty much everyday life. So now as you walk around, you can say, that object is absorbing everything except blue because it looks blue, and so it's scattering blue light. And so on the sky, for example, you look at the sky looks blue because it's sort of scattering blue light as it comes in through the atmosphere. So we'll talk about the sky a little bit later. So that's all for this section of Chapter 5.